Hello and welcome to this video on the most frequently used command for making a layout with KLayout tool. In my case, to speed up the process of the video, I already prepared the layout for an inverter. So what I will do, I will open this layout and then play with it to show you what commands you have available to work with. To open KLayout in edit mode so that you can modify your layout, you type KLayout -E and then the name of the layout that you have prepared if you have one. So in this case will be KLayout -E in inv.gds. And here you are. Now we have the layout that I have previously prepared for the inverter. And as you can notice by expanding, here is I have created actually my inverter by using two predefined parametric cells for the NFET transistor and the PFET transistor so that I don't need to create the transistors from scratch. And this is available through the library of parametric cells that is available for the GF180 MCU, which is there. So if you see here, I have a library of parametric cells that we can go and get it and instantiate it and put it on our layout. If you go and create your layout from scratch, the first important things that you need to remember is that you need to set the grid of your layout to the correct size. And in particular, this is done by going to File, Layout Properties. Here we are, File, Layout Properties. And if you go there, you see that you have this database unit. This database unit must be set to 0.005 micron, which is 5 nanometer. And the way I know which is the size of the grid that I need to set is by, as usual, making sure that you have looked at the documentation of your technology. And so if you go into the documentation, the design geometry design rules for your GF180, you see that the first things things that tells you is that the grid, the design grid, must be an integer multiple of 0.005 micrometer, and that's how you know what to do. Okay, so let me quantify that. Okay, perfect. So once you have done this, you can start to draw your layout. Actually, let me show you another interesting feature here. If you right-click on the Layers tab, you see that there is this hide empty layers. So if you create something from scratch, you want to actually unselect this and have available for you to select all possible layers that the technology provides you. Now, in my case, I have already made everything, and so I know that the layers that I need are just this one, and so I will hide the layers that I did not use it. Okay, perfect. So that is already a good starting point. Now, the next things that I want to actually comment a little bit is that the default colors that we have for drawing the different layers are a bit unusual compared to what most people or most textbook would use it. For example, there is kind of a de facto standard where the poly is actually typically always drawn in red. So what you can do, if you don't like the color that are provided to you and you are used to certain colors, or for whatever other reason you want to change the color, here we have this tab called layer toolbox. And so what you do is, let's say we want to change the poly and I want to make it red. So you select in the layers tab the poly, then we go here on color, select the color and click the red, and now I made it red. If you want to change the style for example, or you can also change the style, the stipple. So for example, let's say I want to make it solid color, then you click here and now it has become a solid red color for the polysilicon. And once you have made your selections and your preferences, the other one thing that you can do, you can save your preferences. And so if you go again into File, and then you click on Save Layer Properties, that will give you the options to save layer property files, LYP. Let's generically call it AAA. So I'm going to save this my preferences here in this AAA.lip. Okay, so let me close this for a second and then let me reopen. So let's say I want to open now my layout with my layer properties preferences. What you can do is KLayout minus E. By the way, there is in the Docker, there has been an alias defined for KLayout minus E, so you don't have to type it all the times. KLayout minus E, you can just type KE. And then you need to pass another options, which is the minus L, to provide the layer preferences. And in this case, I have a preferences here called LIP, and then we go with inv.gds. And so if you run this now, it should open KLayout with my preferences, where I had the poly that has been changed from whatever was the default to a solid red color. Now, my preferences here are very partial, but fortunately, there is Peter Kinget, which is a professor at Columbia, that has defined LIP file, and it has been nice enough to share it. So what we're gonna do it, I'm gonna delete my very partial preferences AAA LIP, and what I'm gonna use from now on is the layer properties defined by Peter Kinget, and he has shared these, and it has called it GFM. I think is PK LIP. So, and then we're going to do inv.gds. And now I'm reopening everything with, I guess, kind of standard color preferences. And, you know, typically the polysilicon is red, metal 1 is blue, metal 2 is purple, and so I'm using these preferences. Okay, so said that, now let me go back and set everything as I had before. So now what I'm gonna do it is I'm gonna show you here how I'm gonna put on the side how would I go about doing the layout. So clearly, if we're doing an inverter, I need an NFET and I need a PFET. So to set the NFET, by the way, actually, before I go do this, let me show you actually a couple of tricks with how to differentiate what I see in terms of layers. As I mentioned already, if you want to hide a layer, all you have to do, or make it visible or invisible, you can just double click on the layer and the layer will either become invisible or visible. But there is actually another way of changing the visibility of your layers. So if you go here on this level tab, if you set this to say 0, 2 will show you all the layers that you have it with respect to the type of hierarchy that we have it. So if I here type 1 and 2, is actually showing me only the layers associated with my parametric cells and what's inside. If I here put it 1, 1, I actually will see just the boxes that surround my 2 transistors. If you, again, you go 0, 2, you're gonna see everything. Then if I do 0, 1, what I will see is actually all the layers that I have put above my parametric cells. So that's a very quick and nice way of just seeing the layers that you may be interested in. So for example, in this case, let me do this. What I'm gonna do here, I'm gonna put a 1 and then 2 here, so that all I see are just my NFET and my PFET transistors. And what you typically do, if you want to place a NFET transistor, you click on this instance here, then you go and here in the library, you specify I want an NFET, and then you go and you place it, and there it is. I have just placed an NFET. Now, if you click on it and double click on it, if you, sorry, let's say select it, so you go with the mouse and drag on it, and then, well, maybe I'm having trouble because, okay, I changed the visibility rules. Here it is. I clicked on the transistor. If I double click it twice, I can go and customize it. So in particular, I don't want a deep end well. I don't want the deep end well guard ring. I actually want to have a tap. This is an NMOS, so I want to have a P tap to tie with the bulk. The width of the transistor that I used in my layout is 1 micro, so I'm gonna make it 1 micro. And then if you look, I have put here a gate contact on the top, so this is gate contact position top, and there it is. And if I say okay, now that's the selection of my transistor, and it looks pretty much like the transistor that I have placed here. The only difference is that in the default that I instantiated, actually the P-tap is on the right side instead of the left side. So if you wanted to have it with the P-tap here on the left side, like I have done it, what you can do is you go into edit actually, and selections, and you see here you have a bunch of very useful operation to edit your layout. In particular, what I'm using very often is this shift horizontally, which has a shortcut of shift H. Then I have the move by, which is the square parenthesis, the shift L for changing layer. And yeah, so these are some of the ones that I use a lot. So the ones that you use a lot, maybe it's worthwhile to learn the shortcut. And then if you go into edit, also you have the copy, the cat, the paste, which are Control C, Control X, and Control V. So these are also very useful command to remember. So I suggest you maybe make a note at the beginning. If you don't remember, you keep it on a post-it or something, because are a command that will become handy very often. So as I said, going back, if I select this and I want to shift where the position of my layout, well, I'm going to do Shift X because now, oops. Not Shift X, sorry. Shift H for flipping horizontally, and there it is. So at this point, you see that the P-tap is on the same side as I have done it in my layout. And then here, then if I select it and I click move, I can move my transistor down. And there it is, more or less aligned with the NMOS transistors that I had already placed. Now, for placing a PMOS, what I can do, I guess the fastest way, if you remember the shortcut, I can use Control C or simply C for copying and placing another transistor here. Then if I go there and I double click on it and I just say, well, look, I want all the PFET there. That's gonna become a PFET. And so here it is. I'm gonna say, okay. And now I have here an NFET and a PFET. And again, the size of the PFET that I'm using is actually 2 microns. So I can select and double click and go here and say, make it 2 micron. And there it is. Now I have a PMOS and NMOS that look exactly like the one that I had already put in my predefined inverter layout. So the other thing that it's important at this point, once I have my 2 transistors placed, if you play with the move, you zoom as much as possible and you play with the move. Actually, if you click the arrows, you don't risk to move anything. So here it is. You go and zoom it a lot and make sure that the 2 transistors are aligned. So great, they are aligned. So I'll just leave them alone. And if they are not aligned, you move them and make them aligned. So the other thing that once you do layout, you should do quite often is make sure that while you place things and so on, you have not violated any rule. And so here it is. If you go on GF180 PDK and you have a run KLayout DRC, you can run the DRC. Here on the background, you see is running. And oops, here I have way too many violations right now with this layout. And this is, if you click on it, the nice things about it is that what happened is it'll pop on tell you the type of violations that you have it, and then also it'll show you where the violations are. So actually, in this case, let me rerun this because by default is running a type of DRC, which is not the one that I want to run it. And so the DRC rules that you want to check are the main DRC rules, okay? Okay, so I'm rerunning the DRC and let's see what it says this time. Hopefully it has picked the correct set of rules, which are the ones in the main. Okay, perfect. So there it is. So now if you look here, it has run the DRC rules, the main DRC rules, which are in this LIR database. And there are a few violations here. So if you go and click on the violations, it will tell you what are the violations that we have. So for example, it's telling that there is a violations where we have N-well spacing rule violated. And if you go here onto your layout rules, you can actually click on N-well and it will tell you what are the rules that you should be actually following. Okay, so and then you go and fix it. Now in my case, I kind of know what's going on. One little trick here, make sure to close the window with the DRC, otherwise you can't continue working. So what I'm gonna do here, I'm gonna select this and I'm gonna do the move to. Okay, remember the shortcut was the open square parentheses. And so let's say I wanna move it on the X direction by a couple of micron and see if that will make the 2D well far away enough that I don't have any violation. So done this. Let's run the DRC again. And there we are now. We have a little bit less violations. Now here we have another violation, and the violation has to do with the fact that I put the two transistors too close to each other. There is a minimum space requirement between the N well and the positioning of the PMOS and where I position the NFET. So I can try to fix this. Again, make sure to close this. Then what I'm gonna do it, I'm gonna select this NFET. Again, I'm gonna use the little, now I wanna move this in the Y direction, and let's actually do not care about doing a good layout and just say, I'm gonna make this far away by 1 micron. And so here is now far away by 1 micron. Again, I'm gonna run the DRC and see if that will fix the violation. Okay, perfect. See, there is right now, I don't have any violation. Okay, so then by the way, here I forgot something. This is, if I want to make it exactly like the original layout, I should double click here and I should change the position of the gate contact to be on the bottom, not on the top. So here it is. I just change it. Then if this is an inverter, I need to have the layout of the two gates. The two gates needs to be connected. Typically, the connection is done by using poly. So you go click on the layer that you want to use it, and then here you have you click on box, so you can draw a box and connect the two poly. Okay, and there it is. Now I have my gates connected, and if you're paranoid or at the very beginning where you don't have much experience, you click checking DRC very often to make sure that you are not doing anything crazy. Okay, perfect. So far, so good. Okay, so I placed two transistors and I have connected the two gates together. Now, if we were to continue our layout, what we need to do at this point is we need to, on the side of the P tap, connect the VDD, on the side of the N tap, connect the VSS of the system. Then I need to connect, so the input of the inverter comes out here from the two gates, and then I connect here the output on this side with metal, and I make the output come out from there. Okay, so that's how our layout is gonna be done. So actually at this point, I'm gonna select this extra stuff that I added to my layout. Oops, that was not really what I wanted, but okay. So you go on the select and select it, and then remember to delete. There is this shortcut Control X. So there it is. I deleted everything and I went back to what we had. So in the case of my layout here, and this is just not the only way you can do the layout. So first of all, I did something a little bit unusual, which is I connected the two gates by using metal instead of poly, like I showed you before. No big deal, I guess. Theoretically, metal has less resistance, but for short interconnections between gate, usually you should really be using poly. It's not going to make any difference to if I use metal practically from a practical perspective. Then the other thing that I have decided to do is I pulled my input and output below. Other ways you could have pulled the input on the left side here in the middle and the output on the right side here in the middle. I would strongly encourage you to read some good textbook on how to do layout or digital logic books uh, or analog books on how to do layout for, doing sound, well done layout rather than just, relying on what I have done it or what I haven't done it. So anyway, let me go here now and uh, deselect the metal for a second. So here I have the contact. So let me, to go from poly to metal, you need a contact. So I'm gonna kind of get rid of any of the things I don't wanna right now emphasize. So I'm gonna just leave the contact here. And so this contact, which is this dark gray here, are allowing you to go both from diffusions to metal or from polysilicon to metal. In this case, I have one here because I use the metal to connect. And by the way, another very important command or features that you have is this tool here where you can measure things. And so in this case, let's say I want to measure, you can use measure or measure edge. So if you go here on the measure, or there we are. So if I am on measure edge, you see that this contact is 0.22 by 0.22. So again, the way I know what kind of size or dimension should I use, I look at the PDK design rule documentation. Okay, so again, I have looked at this before, so I don't want to make the video longer than necessary. Then, for example, if we go here and again, we look at the via, which are basically the same thing as the contact, but it is called via 1, and this is for interconnecting metal 1 to metal 2. Okay, so if I want to make a little connections between metal 1 and metal 2 layers, I need to put a via, and these vias dimensions are 0.26 by 0.26. Okay, so let me put here the metal 1 on again back. So what you see here is that I have connected my two gates with a little box of metal. Then I have also used metal for connecting the drains of my two transistors for creating the output of my logic gate. And then here I have the vias for connecting the VDD and the ground. And so here on top between metal 1 and metal 2, we're gonna put metal. And so that provides the VDD and the VSS. And the reason why I have done it this way is that basically what I try to do is later, because my end goal is to build a ring oscillator, is to just, put cells attached to each other and having the VDD and VSS connected automatically. And then I can also go and easily connect the input and output of cells. I think that is pretty much everything that I can think of in terms of useful command. Minimal set of useful commands that are available for building layout. And I tend to always use boxes for drawing my layer just because it's easy, but you also have the options to use path and polygons if you decide to do so. For example, in this case here, if you go on to select for this thing here, for this part of polysilicon, I decided to use a path instead of using a box, though it is a box. And one thing that it's nice about the path is that if you double click on it, you can very uh, conveniently change the sizing. So for example, if I go and I say make the width of 0.22, that will change the width to be 0.22, and the minimum width for polysilicon is 0.28 microns. So just to see if everything works, I'm going to run another DRC and show you that, well, that was not a good idea to make the polysilicon too small. Let's see. And wait a second and see what the DRC tells us. Oh, actually, maybe it's okay. Or at least that's what he says. It's okay. Or maybe in the database of the rules there is an error, because when you go, let's go look at the design rules for a second. If we go into the design manual on chapter 7 and we look at the polysilicon rules, which are in chapter 7, poly. Okay, we look at interesting. So they have actually, okay, so for doing interconnections, it's actually okay to go all the way down to 0.18, but for the gate width, it has to be 0.28. So let's see. So I was wrong about the rule. Okay, so let's go here, actually, let's close a second and let's double click a second again, and let's try to violate it and make it 0.16 instead of 0.18, and run again the DRC. Ah, there it is. I double click on it, it tells me there is a violation, and it says the interconnect width it has to be 0.18 minimum, but I have done it 0.16. So clearly the design rule checker is not happy about what I've done. Okay, well, anyway, I'm gonna go back, and I forgot what I had it originally, but let's make it a little bit larger, and there it is. Okay, so what else? I think this is pretty much all the commands that I really use it, and that are enough for actually doing a layout. There is another one that I kind of like, which is this partial. So if you select a layer and you wanna, let's say I go here on this metal and I click on partial. This is also kind of nice because it allows me, if I want to stretch things, basically to go on and stretch it, and depending on where you go, it will let you stretch it vertically or horizontally. Okay, so that's really all there is to know for making a layout. So let me now exit and do not save the latest messed up changes, and keep the correct one. Okay, thank you for watching, and see you for next video.